In today's lesson, we will be working on pages 73 to 75 in your Jump 6.2 book. Our lesson today is called Modeling Equations. Your learning target for today is I can use pictures and balances to model and solve equations. Before we get started, let's review some vocabulary. Today you're going to hear the words equation and expression used a lot. They are similar with one important difference. Let's read the definition of an equation. A math sentence that has an equal sign. An equation says that two things are equal. For example, 10 plus 2 equals 12. The left-hand side, 10 plus 2 is equal to 12. Our second example, 5 times 4 equals 20. An expression is very similar. Let's read the definition. A math phrase that is made up of numbers and operational signs, like plus, minus, times, and divide. An example of an expression is 3 plus 2, or 8 times 7. Notice an expression does not have an equal sign. That is the difference between an equation and an expression. Equations have an equal sign. All right, please grab your Jump 6.2 book. This lesson in your Jump Math book has 4 pages. We are going to cross out several questions, so you're going to want to follow along. On page 73, please cross out questions 3 and 4. So that means you are not going to do any parts of number 3. You don't need to cross all of these out, but I just want to remind you, you're not going to do A, B, C, D, E, or F. You're also not going to do question 4. So the only 2 questions you will do on page 73 are number 1 and number 2. On page 74, I would only like you to do question 5 and question 6. Please cross out question 7, question 8, and question 9. On page 75, we are only going to do question 10. Please cross out question 11, 12, 13, and 14. You will also notice that page 76 is part of this lesson. We are not going to do any questions on page 76. Please cross off all questions on page 76. Cross out number 15, 16, and 17. Now we're going to do a couple of examples together. Question 1 says, each bag contains the same unknown number of apples. Let X stand for the number of apples in one bag. Write a mathematical expression for the total number of apples. Remember from our vocabulary review, an expression means that it will not have an equal sign. In the first example, we see that there are 2 apples. We know there are 2 apples, so we're going to use the number 2. We do not know how many apples are in this bag. This is our unknown quantity. We can represent an unknown quantity with a letter. They have chosen X as the letter to represent that unknown quantity. Remember from yesterday, that letter can be anything, but X is very commonly used. Let's try B together. There is an unknown number of apples inside that bag. We are going to represent that number with an X. because the instructions have asked us to let X stand for the number of apples. So, X will represent the number of apples in the bag. Now, I know that there are 3 other apples, so I will write X plus 3. Let's go ahead and do C together because it is a little bit different. In this case, we know that there will be the same number of apples in the first, second, and third bag, but we don't know how many apples are in each bag. We know we have 3 bags. Let's pretend, for example, there are 2 apples in each bag. How would I figure out how many apples we have in total? That's right. If we had 3 bags and they each had 2 apples, we could use multiplication. 3 times 2. Therefore, we would have 6 apples in total. Typically, multiplication is written like this: 3x. That means 3 times x, or our mystery number. So this x is our mystery number. It looks a little bit confusing when we use a multiplication symbol next to the letter x. So normally we eliminate the multiplication symbol and just write 3x. This means 3 times x. There are many ways to write multiplication. Let's quickly review those. So, for 3, let's use 3 times 2 as an example. So we know that we can write 3 times 2. We can also use a little star. Sometimes a star is used for multiplication. 3 times 2. We may also write the number in brackets. 3 times 2. That is similar to writing 3x. We've written the number and the letter next to each other. That means 3 times x. All right, let's try an example from number 2. It says, write an expression for the total number of apples. Write an equation by making the expression equal to the total number of apples. So, we're going to write both an expression and an equation. Remember, equations have an equal sign, expressions do not. In the first example, we can see that we have 1 apple and 2 paper bags. Remember, we don't know how many apples are in the paper bags, but we will assume that both bags have the same number of apples. We have 2 bags times an unknown number, 2x. X is that unknown number. Now, we know we have 1 extra apple, so 2x plus 1 will represent an expression for the total number of apples. Now, we have been told that there are 7 apples in total. That allows us to write an equation with an equal sign. 2x plus 1 equals 7. Let's do one more that has not been done for us. B. There are 10 apples in total. All right. I see 2 bags, 2 mystery bags. Since there are 2 bags, I'm going to start writing the number 2. We're going to continue to use x for that unknown number. So 2 bags times x will tell us how many apples are in these 2 bags. We know that there are 4 other apples. We must add these apples to find the total number of apples. Now, This is an expression because it does not have an equal sign. Let's write it as an equation to show the total number of apples is equal to 10. 2x plus 4 equals 10. This question has not asked you to solve for x, just to write the expression and the equation. Please try 2c by yourself. All right, let's try number 5. It says, the scales are balanced. Cross out the same number of apples on each side to find out how many apples are in the bag. So, by showing a scale that is balanced, we know that both sides are equal. We don't know how many apples are in the bag. But we can see that there are 2 apples on this side. That will cancel off 2 apples on those side. We're going to assume that all these apples weigh the same. That means that there must be 3 apples in the bag. Please try 5b on your own. Before we try question 6, I'd like you to look at the scale. Remember, scales can be used to model equations. Right now, the scale is balanced. On this side, we have 2 apples. The scale is balanced with 1 apple and a mystery bag. Now, we all know that there is 1 apple inside this mystery bag because these 2 apples will balance with these 2 apples. Now, we can keep this scale balanced even if we add additional apples. Let's try to add, we're going to add some green apples just so we can keep track. If I add 1 green apple to this side of the scale, how many apples would I need to add to the other side? That's right, we would need to add 1 more apple to the other side. Whatever we add to one side of the scale, we must add to the other. So, we started with 2 equals 1 plus x. If we added 1 more apple, we could write 2 plus 1 equals 1 plus x plus 1 more. So, we've added 1 on both sides. So we've changed our equation, but we have done exactly the same thing on both sides. As long as you do the same thing, you will not change the balance, and both sides will be equal. Let's take a look at question 6. Always read the gray boxes. They're going to do a great job explaining the next question. An equation is like balanced scales. An equal sign between the sides shows that they are equal. To solve x plus 4 equals 10, subtract 4 from both sides of the equation. So, we had a bag and 4 apples, so x plus 4. Let me write that down here. On this side, there were 10 apples. The scale is balanced, so we'd say that they are equal. If we cancel out these 4 apples, we can determine how many apples must be in that mystery bag. So, we took away 4 apples from each side. By taking away the same number from each side, we will keep the scale balanced. Let's see what that looks like in math language. Let's look at 6a. Again, we started with x. Oh, pardon me. I didn't want to look at 6a. I want to look at this example. So we started with x plus 4 equals 10. In the next row, they have shown that they are subtracting 4 on both sides. When we subtract 4 on the left-hand side, those two 4s canceled out, just like we canceled out the apples, and we're only left with x. On the side with 10 apples, when we take away 4, we are left with 6 apples. So, in 6a, we started with x plus 4 equals 12. To determine what x is, we can take away 4 from each side. Notice the left-hand side, we've taken away 4. That cancels those 4s out, and we're just left with x. If we take 4 away from the right-hand side, we are left with 8. Let's go back and check. If x is 8, let's rewrite the equation. So x plus 4 equals 12. If x is 8, we're going to, oh, it doesn't work right there. Oh, pardon me. Let me try right here. 8 plus 4 equals 12. Is that true? Yes, it certainly is. Go ahead and try B, C, and D on your own. All right, on to the last question in this lesson, question 10 on page 75. The scales are balanced. All bags in the same picture have the same number of apples. How many apples are in each bag? All right, so we can see that there are 6 apples on this side and 3 bags on this side. We can think of that as 3x. X is that unknown number for the number of apples in each bag. So there are a couple ways to think of this. The first way is we could just start sorting our apples into bags. So we know there are 3 bags. This apple could go in the first bag, this one in the second, this one in the third. Now we need to go back to the first bag, second bag, third bag. Therefore, the first bag has 2 apples, the second bag, 2 apples, and the third bag has 2 apples. There are 2 apples in each bag. You may just prefer to think 6 apples going into 3 bags. Well, 6 divided by 3 bags equals 2 apples. There are many ways to think about this. Please try part B on your own, and remember, even though page 76 is part of this lesson, we are not going to do any of those questions. You may cross out all questions on page 76.